Some other really helpful identities that we have are the sum and different identities. There are sum for sine and cosine and difference for sine and cosine. Um, Here they are. You might want to hit pause and write them down because we're going to use them later. I'm not going to derive where they come from, um, but they are extremely helpful later on. So if you think about these identities that we have cosine of 75 is not an angle that we know the values of sine and cosine for. It is the combination of some of them that we know well. If you think about 75, you can get from 45 and 30. So if I wanted to find out what the exact value of the cosine of 75 was, this sum identity can be helpful. So if I treated alpha as 45 and beta as 30, our identity would tell us that we would have the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30, which those angles we actually know. The cosine of 45 is the square root of 2 over 2, and the cosine of 30 is the square root of 3 over 2, minus the sine of 45 is the square root of 2 over 2, and the sine of 30 is 1/2. So we end up with the square root of 6 over 4 minus the square root of 2 over 4. And so the exact measure, since they have a common denominator, the exact value of this angle would be the square root of 6 minus the square root of 2. So we can find out what those angles are. So let's do another one. So 15 is also not one that we know, but 15 can be found by taking 45 minus 30. So alpha would be 45 and beta would be 30. Now you got to be careful with your identity and which angle is which. So I'm going to have the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. So we can evaluate those. So we're going to have sine of 45 is, the square root of 2 over 2. The cosine of 30 is the square root of 3 over 2 minus the cosine of 45 is the square root of 2 over 2, and sine of 30 is 1/2. Let's get some room. All right, so we have square root of 6 over 2 minus the square root of 4 minus the square root of 2 over 4, and we're going to get actually the same answer as before. Square root of 6 minus the square root of 2 over 4. Now, maybe you don't know the exact angles, maybe they are given to you, but we're going to actually go with the fact that we know specific angles. We know what their sine and their cosine are. And we want to find what, we want to find what the cosine of alpha minus beta is. If you went back to your identity page with the identities that we had, you'll notice that the cosine difference angle is the cosine of alpha cosine of beta plus the sine of alpha, the sine of beta. So knowing that, we're just going to take our values that we know. So cosine of alpha is the square root of 3 over, square root of 5 over 3. And cosine of beta is 1 over 4. So then we're going to add that the sine of alpha is 2 2/3, and the sine of beta is a negative square root of 15 over 4. So let's multiply. We're going to get square root of 5 over 12 minus 2 square roots of 15 over 12. So we can write that as square root of 5 minus 2 square roots of 15 over 12.